like we said from the previous video, so I'll be looking at examples for significant figures. So what you can do, you can pause the video, and then using the concepts that have been discussed from the previous video, you can be able to try to answer this, and it will give you a very good idea as to whether there are some concepts that you have to work on, some concepts that you have to review, and then that's going to be very, very helpful. So if you've already gone through them, then we can review the answers together. So okay, so A, what do we have about A? The number has got three significant figures. So how have we arrived at that? So remember the two zeros, which are the leading zeros, they are insignificant. Okay, so those ones are removed, and then one, that's a non-zero digit, so that's significant, and then 5 as well is. But remember, there's a zero in between. That's a captive zero, and remember that the captive zero is significant. So that's how we're arriving at 3. Then a chemist records the mass of 0.050080. So how many significant figures? So that's 5. Okay, now how are we arriving at that? Remember, the first two zeros are insignificant because they are leading zeros, and then when 5, okay, and then 5008. So you see those two zeros between 5 and 8, they are captive zeros, so they are significant, right? So far we've got how many? 4 significant figures. But how are we arriving at 8? That last zero, that trailing zero, is significant. Why is it significant? It's because there is a decimal point in this number. So this number contains a decimal point. Therefore, that trailing zero is going to count as being significant. So that's basically how we go about it. Then when you go C, okay, so we've got that particular experiment. Now, when you look at that number, the fact that it's been written in exponential notation, that's something that I mentioned in the earlier video. The fact that it's been written in exponential notation makes it really, really easy for us to be able to count the number of significant figures. So we see there we've got 8.050. So you see that 8, of course, it's a non-zero digit, so it counts, and then that 0 between 8 and 5 will count as well because it's a captive zero, and then the trailing zero is also going to be significant because this particular number has got a decimal point. So that's how we're arriving at 4 significant figures. So that's basically that. Now, rules for significant figures in mathematical operations. So okay, so here we're going to look at first for multiplication or division. So basically what we're going to do here is for multiplication or division, the number of significant figures in the result is the same as the number in the least precise measurement used in the calculation. So when we talk about least precise, we are basically talking about the number that has got the least significant figures. Okay, so that means that when you are multiplying or dividing two numbers, what's going to determine the number of significant figures that your answer is going to have is going to be the number of significant figures that the least precise measurement has. Or basically, so if you're, like for example, we are multiplying 4.56 and 1.4. So we'll look at so you see that the first number has got three significant figures, the second one has got two significant figures. So we see which one of these, has got a has got lower precision. It's 1.4, isn't it? Because it's got two significant figures, whereas the other one has got has got three significant figures. So therefore, we know that after finding our answer, 6.38, it has to be corrected to what? To two significant figures. So that's why we're writing 4, or rather 6.4 there, right? So that's really how we go about it. Then for addition or subtraction, the result, so here the concept is a little bit different. So don't confuse the two. So for multiplication or division, the number of significant figures in the result is the same as the number in the least precise measurement used in the calculation. So that's for multiplication and division. Now for addition or subtraction, the result has the same number of decimal places as the least precise measurement used in the calculation. So catch the difference. It's not significant figures for addition or subtraction, it's number of decimal places. Now this is very, very important because if anything, this is one of the key mistakes that people make when it comes to the addition or subtraction. So here it's number of decimal places. So you see here for this particular calculation, we are adding 12.11, 18.0, 1.013, and so you see that the first one has got two decimal places, the second one 18.0 has got one decimal place, then the last one has got three decimal places, right? So you see which one has got at least number of decimal places. It's 18.0, which has got one decimal place. So meaning that that answer that we found after adding these things, 31.123, 31.123, you see that we are going to round it off to one decimal place. Get the difference, not significant figures here, but decimal places. So please take note of that. Okay, so note that for multiplication and division, significant figures are counted, whereas for addition and subtraction, the decimal places are counted. Okay, now let's talk about the concept of rounding off. So rounding off is something that's very, very important, and it's one concept that you're going to make use of from time to time. So in a series of calculations, carry extra digits to the final result, then round off. So here's the thing: whenever you are calculating things, especially in chemistry, the chemistry department tends to be very strict. So what you want to do is that whenever you're calculating something, keep all the extra digits. Don't round off, because you find that if you've got 6 steps in your calculations and you keep rounding off 6 times, your answer, you may be thrown off the answer. Okay. Oh, yeah. So that's, take note of that. Carry the extra digits to the final result, then round off the final result. Okay. Okay, so then the second rule: if the digits to be removed. So now, if for instance you are trying to round off something, if the digit to be removed is less than 5, the preceding digit stays the same. So basically what we are looking at is, let's look at that particular example that we looked at. So there, when we were rounding off, you see 6.38. Therefore, the example on multiplication and division, 6.38, and rounding it off to two significant figures. What did we do? You look at the three, where the two significant figures ends, and then you look at the number that follows. Is it less or greater than 5? If it's greater than 5, or rather if it's 5 or greater, yeah, let me put it that way. If it's 5 or greater, then you add 1 to the what's this, then you add 1 to the preceding number. That's how we got our 6.4. Makes sense, right? So if the digit to be removed, like 8 it was in that case that we are from looking at. So if it's less than 5, the preceding digit stays the same. So for instance, 1.33, we want two significant figures. So we see that the number that is to be removed, which is 3, which is the third significant figure, we see that because it's less than 5, that number remains 1.3. But then if it's equal to or greater than 5, so it's equal to or greater than 5, then the preceding digit is increased by 1. Like you saw there, from 6.38, it went to 6.4. And then if we've got 1.36, it rounds off to what? To 1.4. So that's an important point that you want to take note of. Then there's the concept of rounding off. It's very, very important to don't. Okay, so suppose the number 4.348 needs to be rounded to two significant figures. So here what we're going to look at is rounding off to two significant figures. We only need what? 4.3, right? Now you see that the number that comes, okay, the number that comes after 3 is what? It's 4. It's less than 5. So we're just going to leave it what? We're just going to leave it to 4.3. So it's incorrect to round sequentially. So you can't do where you say, okay, 8 rounds the so that 8 towards the end rounds off the 4 to 5, then the 5 rounds off the 3 to 4. No, you can't do that. You don't round sequentially. You just look at the number that comes after that particular number that you are focusing on. Okay, so that's that. Then here is just saying, remember to carry all the digits until the last question. So here it's just a couple of examples to just help you go through and just to see if you are comfortable with the concepts. So take time to go through this, and then they should be very, very helpful. So that's really about it. So the next part will be talking about conversions. So the next part will be talking about conversions, and then talk about density, and then yeah, so follow the next videos.